Zener diode is one of the special purpose diode. It is designed to operate under the reverse bias in breakdown region and used as a voltage regulator so that to get the constant voltage at the output. Zener diode, in contrast of the simple PN junction, is fabricated by heavily doping both the P side and the N side of the junction, due to which depletion region form is very thin and the electric field of the junction is extremely high. And when the applied reverse bias reaches the breakdown voltage of the Zener diode, there is a large current in the circuit. Symbol which is used in the electrical circuits for Zener diode is shown here. This is the symbol of Zener diode, which is slightly different from the symbol of the PN junction. The IV characteristics of the Zener diode is drawn by the graph between the current and voltage. On x-axis we take V voltage in volts. On y-axis current is taken. During the forward bias current will be of the order of milliampere, and in reverse bias current will be order of microampere. If we draw the graph during the forward bias condition, the graph shows that current is 0 up to a threshold voltage. After that this current start to increase. So this is the graph of the forward bias. It is the threshold voltage, VTH, or cutoff voltage. And in reverse bias condition, the current is of the order microampere, which remains constant independent of the applied voltage. And at the breakdown voltage, the current increases rapidly with very small change in the reverse bias voltage. This reverse current is due to the flow of the electrons, which are the minority carriers from P to N, and holes, which are the minority carrier in the N type of semiconductor, to the P region. At the breakdown reverse bias voltage, the electric field strength is high enough to pull the valence electron from the atoms on the P side, which are accelerated to N side, and these electrons account for the high current observed at the breakdown. The emission of the electrons from the host atom due to the high electric field is known as the field emission, and the emission of the electrons from the atoms due to the high electric field is known as the field ionization. And the order of the field required for the field ionization is of the order of 10 raised to the power 6 volt per meter. Because Zener voltage remains constant even though the current through the Zener diode varies over a wide range, this property of the Zener diode is used for regulating the supply voltages, which provides the constant voltage at the output. So first we will draw the circuit for the Zener diode as a DC voltage regulator. Zener diode is used as DC voltage regulator, in which at the input terminals the source voltage is applied, which is unregulated voltage. In series of this, there is a resistance which is Rs, say source resistance, and this resistance is in series with the Zener diode, which has the breakdown voltage Vz. This Vz is constant for the Zener, and across the Zener diode, a load resistance is connected where output voltage is received, and this output voltage is the regulated voltage. That means constant voltage. Suppose from the source a current Is is drawn, and this Is at the junction A divided in two components. One is Iz, this is the Zener current. Another is passing through the load resistance, suppose this is IL. So from Kirchhoff's current law, which says that incoming current at a junction will equal to the outgoing current at that junction. So Is will be equal to Iz plus IL. This implies that this IL is equal to the voltage across the load resistance, which is equal to the Vz, because voltage across Zener is constant, and is divided by RL, so this gives the load current. Similarly, we can find the source current. This source current will be equal to the voltage across the Rs divided by the resistance Rs, and voltage across Rs will be equal to the Vs, this is the source voltage, minus voltage at the junction point A. This lower end suppose at the grounded or the 0 volt, then in comparison to this A point will have the potential Vz and the end of the supply voltage has the potential Vs. So we can say that potential difference across the Vs will be Vs minus Vz, and it is divided by the Rs. So this is the source current. So Zener current will be equal to Is minus IL, and it will be equal to Vs minus Vz divided by Rs minus Vz by RL. And this equation or condition will be used in solving the problem related to the Zener diode as a DC voltage regulator.